Ever notice how the smallest things cause the biggest headaches? Atoms are no exception. You're sitting in chemistry class, staring at a periodic table that looks like a bingo card designed by someone who hated fun. Your teacher's droning on about protons and neutrons, and you're wondering why any of this matters. But here's the twist. Everything you're touching, breathing, even thinking with right now is made of particles so small that billions of them could fit on the head of a pin. Now, imagine you're a scientist in the early 1900s, trying to convince people that solid matter is actually 99.9% empty space. How do you sell that idea? With models that keep changing every few decades, apparently. The truth is, atoms are the ultimate con artists of the physical world. They promise to be the fundamental building blocks of reality, but the closer you look, the more they fall apart into smaller pieces. First it was electrons, protons, and neutrons, a nice, tidy family. Then quarks showed up to the party, and suddenly we're talking about things called charm and strange, like we're naming ice cream flavors instead of subatomic particles. Here's where it gets really wild. Atoms aren't even solid. If an atom were the size of a football stadium, the nucleus would be a marble at the 50-yard line, and the electrons would be gnats buzzing around the upper deck. Everything in between? Pure nothingness. So when someone asks what you're made of, the honest answer is mostly vibes and electromagnetic forces. Doesn't quite have the same ring as stardust, does it? But that's the reality scientists discovered when they started poking around at the atomic level. The whole thing started innocently enough with ancient Greeks spitballing about indivisible particles while lounging around in togas. Fast forward 2,000 years, and we've got particle accelerators the size of cities smashing atoms together just to see what spills out. It's like breaking open a Russian nesting doll and finding 17 more dolls, except some of them only exist for a trillionth of a second. Picture yourself trying to explain this to someone from the 1800s. Yeah, so matter is made of invisible particles that are somehow both waves and particles at the same time, depending on whether you're looking at them. They'd think you'd been hitting the opium pipe a little too hard, but that's quantum mechanics for you, a field where particles can be in two places at once, where observation changes reality, and where cats can be simultaneously dead and alive until you check on them. Schrödinger's cat isn't just a thought experiment. It's a pretty good metaphor for how bizarre the atomic world actually is. The real kicker? We use this knowledge every single day. Your smartphone, your microwave, your LED lights, all of them work because scientists figured out how to manipulate these lying little particles. We've built an entire technological civilization on understanding things that don't even play by the rules we thought governed reality. Think about that for a second. We trust atoms to form the computer chips that run our banks, our hospitals, our entire infrastructure. Yet, at their core, they're governed by probability clouds and uncertainty principles. It's like building a skyscraper on a foundation of maybe. And here's the part that really messes with your head. Atoms themselves are made up of things that might not even be things in any meaningful sense. Quarks are held together by particles called gluons, because apparently physicists have a sense of humor and the whole system is mediated by forces we can measure but never fully visualize. Some scientists spent their entire careers studying these particles, winning Nobel Prizes for figuring out increasingly tiny subdivisions of matter. Then you've got the theorists claiming there might be even smaller stuff, strings vibrating in 11 dimensions, or whatever fever dream the latest paper proposes. The rabbit hole just keeps going. Meanwhile, chemistry teachers everywhere are still drawing neat little circles with dots representing electrons, like atoms are tiny solar systems. It's a lie, but it's a useful lie, kind of like how we pretend the Earth is a perfect sphere when it's actually an oblate spheroid with mountains and valleys. Sometimes reality is too messy for a whiteboard. The practical joke continues in everyday language. We say things are solid or hard when really they're clouds of probability holding each other at bay through electromagnetic repulsion. When you sit in a chair, you're not actually touching it. You're hovering a few nanometers above it, held up by electrons that refuse to occupy the same space. Mind-blowing, right? Corporate marketing teams have figured this out too. Everything's quantum now, quantum computing, quantum healing crystals, quantum toothpaste probably. They're banking on the fact that quantum sounds sophisticated and mysterious, which it is, but slapping the word on random products doesn't suddenly make them revolutionary. It's the atomic equivalent of putting turbo on a minivan. But let's give credit where it's due. The scientists who unraveled atomic structure weren't trying to deceive anyone. They were just following the evidence, even when it led them to conclusions that sounded completely insane. Rutherford shot particles at gold foil and discovered the nucleus. Bohr proposed electrons orbit in specific energy levels. Heisenberg proved you can't measure everything precisely at once. Each discovery made the universe weirder, not simpler. And that's the thing about atoms making up everything. They literally do compose all matter in the universe, but they also make up the rules as they go along. Different contexts, different behaviors. An electron in a hydrogen atom acts differently than an electron in a copper wire. Same particle, completely different vibe depending on the situation. The really unsettling part? We still don't know if we've hit bottom. Every generation of physicists thinks they've found the fundamental layer, and every generation gets proven wrong. Atoms gave way to subatomic particles, which gave way to quarks and leptons, which might give way to strings or loops or who knows what. It's turtles all the way down, except the turtles keep subdividing. So yeah, atoms make up everything in the most literal and figurative sense possible. They construct reality while simultaneously being the universe's greatest storytellers, spinning tales of solidity and substance while being mostly empty space held together by forces we can barely comprehend. Every object you've ever touched, every person you've ever met, every star in the sky, all of them elaborate conspiracies of atoms pretending to be substantial. Here's the beautiful irony. Despite being fundamentally unreliable narrators, atoms are incredibly consistent. The carbon atom in your body behaves exactly like the carbon atom in a diamond or a pencil lead. They follow rules, even if those rules involve probability and uncertainty. It's organized chaos at the smallest scale. The scientific community keeps refining the story, publishing papers, building bigger accelerators, and developing more complex mathematical frameworks. Each breakthrough reveals another layer of atomic deception, another way these particles aren't quite what we thought they were. And we eat it up because understanding atoms means understanding ourselves. What started as a pun, scientists don't trust atoms because they make up everything, turns out to be a pretty accurate summary of modern physics. We've built our entire understanding of material reality on particles that are simultaneously real and abstract, measurable and uncertain, fundamental and composite. They're the unreliable witnesses at the foundation of existence. And tomorrow? Tomorrow, some researcher will publish a paper showing atoms are even stranger than we currently imagine, and the whole beautiful mess will continue. That's the game of science, chasing truth through layers of atomic misdirection, one particle collision at a time.